You're walking on the street when suddenly...
Okay. Your level of secondhand fear right now probably depends on where and when you're watching this, but what is it about some viral epidemics that makes them seem scarier and sneakier than others? The answer isn't luck, it's time.
A virus's only goal is to reproduce, but to get around our immune systems, they have to be sneaky by using time to their advantage. So, how can we observe this use of time? Have you heard of something called the SEIR model?
Say we have a city separated into 3 buckets based on their stage of viral infection. Everyone begins as water in the susceptible or uninfected bucket. As the virus enters the city, water begins to flow from the susceptible bucket into the infected. Over time, the rate of infection increases because there are more carriers.
The rate of infection also varies with the probability of transmission between 2 people.
The infected bucket's starting to get really heavy. Luckily, people begin to recover, meaning they get adaptive immunity to recognize and prevent future infection. So, as we pour from susceptible to infected, we'll eventually begin pouring from infected to recovered. Over time, hardly any new infections will occur, so the buckets will virtually stop pouring. Using this model to graph epidemics allows us to make predictions. For example, by looking at the rate of infection, we can predict when the infected population will begin declining. We can even find out how individuals will spread the virus by dividing the average transmission rate by the average recovery rate. This number tells us that if one person can infect, for example, 3 people, those 3 people could each infect 3 more, causing the infected population to grow rapidly. Epidemiologists adapt the basic SEIR model to add realism through factors like mortality, social distancing, and isolation after testing.
But how can we know to take these precautions before things get really bad?
We must first include an exposed, but not yet infectious, population. To understand why, let's look at a retrovirus like HIV. HIV infects with a low concentration or viral load, allowing it to discreetly take over white blood cells and copies genetic information with reverse transcriptase enzymes. This period of activity is called latency, the time between exposure and infectiousness, during which the virus is active but temporarily unable to spread from one host to another. Viruses maintain sneakiness by using latency differently. Some viruses, like the flu, have a short latency compared to HIV, but can evade detection by spreading before the host shows symptoms. Ebola also has a short latent period, but can overwhelm the immune system with a high temperature and viral load. This variation is why differentiating between exposed and infectious is so important. So from what we've seen, viral epidemics can seem scary and sneaky, but your probability of infection isn't simply luck-based. By looking at how viruses utilize their time with the SEIR model, we can see how epidemics take shape on a micro and macro level, allowing us to make predictions. Knowing this, we can use time to our advantage and prevent viruses from spreading by temporarily isolating ourselves and washing our hands to our favorite song for just 20 seconds. Thanks for watching!